I hope the screen is visible, right? Good evening to one and all. Okay, today we are going to discuss about the new topic, that is extending the range of meters. Okay, first of all, tell me why extension of meters are required. So, what do you mean by extension? So, extension means extending the range. So, extension means range of meter, because let us take an ammeter, okay, which is going to measure current. Okay, let us go for 0 to some 10 amps of ammeter is there. Okay, nothing but this meter, a meter is capable of measuring 10 amps, 0 to 10 amps. Okay, it's having the terminals, right? The meter will be able to measure 0 to 10 amps of range. Now, if you want to extend, if you want to measure higher ranges of current, let us say I want to measure 15 amps of current. Okay, listen carefully. I want to measure 15 amps of current, but I have given only a 10 amps range of ammeter. Let it be whether it is MI type or MC type, whether you are going to measure AC or DC, let it be that and all secondary. Okay, so I have given you the 15 amps of input current. So the input current is 15 amps, and the meter is nothing but ammeter is nothing but 0 to 10 amps of range. It will measure up to 10 amps. Then beyond the 10 amps, I am giving the input as 15 amps. Okay, then is it possible to measure to with the help of ammeter? Tell me in the chat box. Can you measure 15 amps with the help of 10 amps range ammeter? Is it possible to measure with a existing ammeter? Respond in the chat box. No answer from anyone. No, sir, not possible. No, no. Okay, everyone is saying no, but it is available only with the 10 amps meter. I'm having only 10 amps range ammeter. I don't have 15 amps of ammeter. So what I can do, I will measure 10 amps. I will measure 10 amps from the meter, and there is an excess 5 amps is there. 5 amps should be bypass. What will be bypass here? What will be bypass? Bypass means if the current is more than the range of a meter, if the input current is more than the range of meter, then the excess amount of current can pass through another resistor. So the 5 amps I can use a resistor where 5 amps can flow through the resistor, and the remaining 10 amps is going to flow through the meter, because my ammeter is able to measure 10 amps only, but I am giving the input as 15 amps, right? So it is possible to measure the higher ranges of currents with the help of existing meters. So existing meter means 10 amps meter. Higher ranges of current means, let us say it's a 10 amps meter. We are going for 15 amps of current or more than that amps of current, right? So there are different types of ammeters used in measurement to measure the currents. Of course, moving iron type to measure both AC and DC you can measure. And MC type can be used for DC measurements only, right? And but every instrument has having its measuring range capacity. That's what I said, it's range. So here what I have taken, 0 to 10 amps of range. So this meter will measure up to 10 amps of capacity. Okay, then for example, okay, here 0 to 10 100 milliamps meter has taken. Now if you are getting more than that current, if you are getting more than that current, then what we are doing, It is impossible to measure the higher currents which are more than the measuring range of ammeter. Yes, of course. So it is of 10 amps of meter, then we can measure up to 10 amps. It is difficult to measure beyond 10 amps. Okay. Therefore, it is necessary to bring up these large current to a value within the range of instruments. Nothing but my meter is capable to receive 10 amps of current. Okay, but I am giving 15 amps of input current. Then I should pass only 10 amps through the meter and the remaining 5 amps should pass through the bypass. Now, for extending the range of ammeters, devices use either we can use shunt or current transformers also. Anyhow, around about the current transformers, we are going to discuss in detail in the next chapter, second chapter. So shunt, what is a shunt? Shunt means short circuit. Shunt means short circuit. So a short circuit path is going to be used in AC measurements as well as DC measurements. Okay, but whereas current transformers are used only in the AC measurements. So about the current transformers while measuring the AC supply, that we are going to discuss in detail in the second chapter. Now we are discussing about DC measurements, right? Now, so in measuring instrument, the shunt refers to a low resistance path. So one thing you need to get the confirmation, nothing but always the current flowing in a low resistance path. We know the definition for resistance. Resistance is nothing but the element which opposes the flow of current. The element which opposes the flow of current. So here, whatever the resistance we are using is opposing the flow of current into the circuit. Now we'll see. Panel. Let us observe this circuit diagram. The input current capital I is nothing but the amount of current what we are need to measure. So this is our input value. So we should not, as I said, whatever the input current that we should measure, whatever the input current that we should measure. But whatever the meter we are selecting, that meter should be normally it should be within a range. Otherwise, we have to go for extending the range of a meter. Now observe this. This is the input current. Let us say this is 15 amps of current is input current. These 15 amps, a meter range is of 0 to 10 amps. Okay. Now what we are doing? We are giving 15 amps of input, but the meter is capable to measure only 0 to 10 amps of current only. So this IM, nothing but the amount of current flowing through the meter. IM stands for the amount of current flowing through the meter. M stands for meter. So meter current, nothing but 10 amps. So this meter will measure up to 10 amps only. So what is the excess of current is there? 5 amps current is there. So ISH, here I am going to use nothing but the total 15 amps can be divided into 5 and 10. See, observe this arrows. Total 15 amps of current is splitting nothing but in a parallel path. In a parallel path, the current is going to split according to based on their amount of what you can say resistance value. So here I am going to connect a resistance, shunt resistance. Observe here. This is a shunt resistance so that RSH can be kept in parallel with the ammeter or basic meter, whatever you can call it as. Now here we are using ammeter. So in parallel with the ammeter, I am going to connect a shunt resistor. So what will happen? The meter is capable of receiving 10 amps of current and the remaining 5 amps should pass through the shunt resistance. So you need to select how much amount of resistance is going to keep at shunt resistance. Let us say the meter is having certain amount of internal resistance. The ammeter or voltmeter or wattmeter, whatever it may be, it is having certain coil, as we said, as we have discussed in the previous cases. Electrodynamometer type watt, what you can say, meters. Okay, voltmeter, ammeter, wattmeter, whatever it may be. So here, the meter consisting of a coil, that coil consisting of certain amount of resistance. So this basic ammeter. So here we are using you are measuring the ammeter. Nothing but we are extending the range for ammeter currents. So here we are using ammeter. This ammeter is capable of gathering or collecting the current or measuring the currents up to 10 amps, then it is having certain amount of internal resistance Ri. Ri stands for internal resistance of the meter. And here we are using a shunt path, RSH. Now, tell me the answer for the question. Ri and RSH, which should be more? Shunt resistance or internal resistance of the meter? Tell me in the chat box. The internal resistance of meter and shunt resistance. So which should be more and which should be less? Ri less, RSH more, like that you can just type in the chat box. I am seeing your answer. RSH is more. RSH is more. Resistance is more. Okay. Any other comments? Any other answers? So everyone is saying RSH is more. Any other answer? So we are having only two answers, whether Ri should be more or RSH should be more. So only three people are chosen. That is Nagur, Gautam, Keshav Reddy has chosen RSH is more. Then Naga Fanindra said RSH is more because it consisting of more number of turns. So turns అనేది కాదు ఇక్కడ. It's a resistor, that's all. Okay. 1 kilo ohm resistance size మీరు DC ల్యాబ్ లో చూస్తుంటారు. 1 kilo ohm resistance size తర్వాత 500 ohms resistance size ఆల్మోస్ట్ సేమ్ ఉంటాయి. బట్ ద మెటీరియల్ వాట్ దే హావ్ యూజ్ మైట్ బి డిఫరెంట్. డోంట్ గో ఫర్ ద నెంబర్ ఆఫ్ టన్స్. ఇక టన్స్ ఏమి ఉండవమ్మా. మనోజ్ కుమార్ యూ సెడ్ RSH అంటే మోరా లెస్సా? Manoj Kumar, more. So everyone is saying RSH is more, but no answer has said. I have seen Ri is more. Okay, once again I will define what is resistor. Resistor is nothing but it is the element which is going to oppose the flow of current, which is oppose the flow of current. Now compare Ri and RSH. Okay, what everyone is saying about RSH is more resistance. So from where we are getting the incoming current? From this side. So plus and minus, let us say. So 15 amps of current I is flowing. So as we know, the current is always choosing the low resistance path. Current is always choosing the low resistance path because resistance is nothing but obstruction to flow the current. That is the basic definition for a resistor. Now, if Ri and RSH are there, everyone is saying RSH is more, then Ri is less. It means that Ri is less. So the current will always choose low resistance path. Okay, the current is always choosing low resistance path. Then automatically the 15 amps current will flow through RSH or Ri. Ri only, obviously. Because Ri is less. What as of your answers, so far around 10 members has responded. Ri is less and RSH is more. If RSH is more, what will happen? Current will not enter into RSH. Current will pass through Ri. Ri is nothing but meter, internal resistance of the meter. Now the meter is capable of carrying only 10 amps of current. If it is having less resistance, what will happen? It will allow more amount of current. Then what will happen? The meter will get damaged. Keep in that mind. The meter will get damaged. Always Ri should be more than RSH. Shunt resistance will be less. Then only we can bypass the excess amount of current and the remaining amount of current only will pass through the meter. So meter is maximum we can measure, or this meter, whatever the example what we have taken. In this meter we can measure up to 10 amps only. There is no doubt about it. We can't measure beyond that. But what is the excess amount of current is there? 5 amps of excess amount of current is there. that 5 amps is going through the shunt resistance. So if Ri is more than RSH, okay, then RSH, through the RSH the current will flow. Otherwise, what you said RSH is more means, then what will happen? Current will not allow, nothing but RSH will not allow that 5 amps of current. What will happen? Then it will, that current will flow through, oh, what I can say, what it is, meter only. So 15 amps of current is flowing through the meter, then meter will burn out. Is it clear? Always the shunt resistor should be minimum. So here we can have another sentence. It acts as a divider, current dividing. Here we are dividing the current. It acts as a divider and the maximum percent of current measured will pass through it. Okay, so we are dividing the current. So in the parallel circuit, we are having current division. We are going to have current division. Now for the same circuit, Im is the full scale current of the basic meter. Nothing but maximum current we can measure through the meter, Im. Okay, then ISH, current flowing through the shunt. Now we are going to derive how much amount of resistance we are going to connect in parallel with the meter. That the derivation we are going to see. Rm, nothing but the meter internal resistance. So earlier I said Ri, internal resistance. Now I am saying meter resistance. Rm stands for internal resistance of the basic meter, nothing but a meter, let us say in this case. Next, RSH, resistance of shunt. Okay, so Im is nothing but the meter current. ISH is nothing but the current flowing through the shunt. Rm is the meter resistance. RSH is the shunt resistance. And I, capital I, the amount of current being measured, nothing but this is the current what we are expecting, nothing but to measure that current. And M is the multiplying factor. Okay, we will discuss what is M, how we are going to get M in the next slide. So for the same circuit, so Mr. Vamshi Krishna just now joined, so already class started half an hour ago. It is not good, so kindly join at the regular times. Okay, don't be delayed. Okay, right. As the shunt is connected in parallel to the basic meter, the voltage drop across the shunt will be equal to that of the basic meter. Nothing but here you can observe the meter and the shunt are both are connected in parallel. So across these meters, how much amount of voltage will be there? Equal voltage will be there. Because in the parallel circuit, current is dividing and voltage is maintained constant. And the voltage is maintained constant. Okay, so across the shunt resistance, the amount of voltage is nothing but the amount of voltage what we are applied here. Let us say this is plus and minus. Here I have applied some V volts. So the same V volt is across the meter and the same V volts is across the shunt. So across the meter we are getting, so in the parallel we know that the voltage is constant, right? Then Im Rm, nothing but the amount of current voltage drop. Now we are saying voltage drop. Im into Rm, nothing but voltage drop across the meter is equal to the voltage drop across the shunt resistor. So Im Rm equal to ISH RSH. Okay, you can note down this circuit diagram and expressions also. Okay, take your book and you can note down, right? Then from the figure what you can say, the total current I is equal to Im, nothing but the current flowing through the meter, plus ISH, the shunt current, nothing but the current flowing through the shunt. Then what you require, how much amount of current should pass through the shunt. So we are going to calculate for ISH. So ISH is nothing but, so from this expression I equal to Im plus ISH, we are calculating I equal to I minus Im. So this much amount of current should pass through the meter. Now substitute that second equation in the equation number 1. So Im Rm equal to ISH RSH. So in that we are substituting ISH equal to I minus Im, right? Now see this derivation. So Im Rm equal to, okay, Im Rm equal to I minus Im. So nothing but here whatever the ISH is there. Instead of ISH, we are representing I minus IM. I minus IM. So that value we have substituted in this equation. So I minus IM into RSH as usual. Okay, so IM RM equal to IM RM equal to I minus IM into RSH. Right. Now from this we need to calculate RM value. So RM, because the meter resistance we need to calculate here. Okay, RM equal to, okay, I by IM, nothing but we are dividing. So this will comes to here. So I divided by, sorry, what it is. So we are going to calculate that I divided, okay, I minus, okay, anyhow we are calculating this I divided I minus IM divided by IM, nothing but I by IM minus 1. So this is, I think, 1, this is I divided by IM minus, okay, so here we can have this variation so that we can have RSH into RSH. So that is nothing but, so RM by RSH, nothing but the factor what we are calculating, RM divided by RSH equal to I by IM minus 1. This is 1, not I. This is 1. Okay, it's a typing mistake. ఎక్కడ దొరికిందన్నా ఇది డైరీలో అతికిచ్చేసి, ఓకేనా, మర్చిపోదు, ఇప్పుడు అతికిచ్చి. Right. So I divided by IM minus 1. So RM by RSH equal to, the ratio is nothing but I by IM minus 1. Okay, just note down in your notebook. Right. From that, I divided by IM equal to 1 plus RM by RSH. Now take this equation as equation number 3. Okay, note down these expressions. I will give 1 minute time. So from the circuit diagram, we are representing the voltage drop across the meter and across the shunt. We are calculating IM RM equal to ISH RSH. Now I nothing but IM plus ISH, and we are calculating ISH value as I minus IM. That value we are substituting in the equation number 1. IM RM equal to I minus IM into RSH. Okay, now we are making some more derivation, so that finally we are going to get I by IM, nothing but ratio of currents. I is nothing but the total current to be measured, and IM is nothing but the amount of current can measure through the meter. Okay, equal to 1 plus RM by RSH. That is the expression what we have obtained right now. The ratio of I by IM is called the multiplication factor, that is represented with small m. So m equal to I divided by IM, that is the multiplication factor. I divide I m equal to I by IM. Now take this equation as number 4, and now substitute this equation in equation number 3. Now we are going to get m equal to, nothing but I by IM equal to 1 plus RM by RSH. 1 plus RM by RSH. Okay, now from that we are going to calculate RSH value. So here, how much amount of resistance can be connected across the, or in parallel with the meter. So finally we are going to calculate the expression for RSH. So this much amount of resistance, nothing but RM divided by, RM is nothing but the meter internal resistance divided by M is the multiplication factor minus 1. So RM by M minus 1 is the value of resistance. This much amount of resistance can be made in parallel with the meter. So where M is nothing but, I by IM. I is the total amount of current to be measured, and IM is the amount of current passing through the meter, nothing but meter range. Okay, so RSH equal to RM by M minus 1. Right, note on this expression. right? Now, the meter deflection theta. So definitely the meter will have certain amount of deflection theta. It is directly proportional to the meter current Im, as we know already that we have already derived several expressions, right? That is nothing but theta is proportional to Im. Theta is proportional to Im, nothing but the angle of deflection is proportional to the meter range, nothing but the amount of current to be measured through the meter, and which is also proportional to the amount of current to be measured. I is nothing but the amount of current to be measured. So theta is proportional to Im, as well as it is also proportional to capital I. Okay, where Im is the meter current and I is the current to be measured. So the meter deflection is directly proportional to the total current being measured. Okay, so nothing but A equal to B equal to C, nothing but A equal to C, like that. Theta is also proportional to I. Hence, by connecting a proper value of shunt, by connecting a proper value of shunt and calibrating the meter scale in terms of M into Im, in terms of M into Im, so that we are going to get the capital I. The range of ammeter can be extended like that. Okay, so we are going to take the multiplier. M is nothing but I by Im. So this much amount of resistance, nothing but multiplier, can be connected across this, so that we can have the ammeter range can be extended. So RSH, we have gone through the formula. So RSH equal to, so in the previous expression we will have that formula Rm by M minus 1. So this much amount of resistance we are going to calculate we are going to connect across the or in parallel with the meter. So the range of ammeter can be extended by using shunt. Okay, hence by adding number of shunts. Why you are going for number of shunts? Because I am having 10 amps of meter, let us say 0 to 10 amps of meter. Okay, I am having 0 to 10 amps of meter, but I want to measure, listen carefully, 15 amps, 20 amps, 25 amps, 30 amps with the same meter. Keep in that mind. With the same meter, I want to measure 15 amps of current, 20 amps of current, 25 amps of current, 30 amps of current. So these are the currents to be measured, nothing but capital I values. Capital I values. And this is the current Im. Nothing but Im is nothing but 10 only, always, because I am providing you 0 to 10 amps range of ammeter only. So it will measure up to 10 amps, full scale value of the meter, full scale value of the meter. But the amount of I as 15 amps, 20 amps, 25 amps and 30 amps. So I value will varies from 15 to 30, like that. Okay, then what about M? M equal to I divided by Im. M equal to I divided by Im. So we need to use multiple. So here 4 currents we need to measure now. So 4 multipliers or 4 shunts can be connected in the circuit. Now observe this circuit. RSH1, RSH2, RSH3 and basic meter. The ammeter what we are going to use. Now here we can have a changeover switch, range selector switch. We can call it as range selector switch. So if I connect at point 1, what will happen? RSH is in parallel with RM. RM is nothing but meter resistance. Okay, if I connect at this point, what will happen? RSH will be in parallel with the meter. If I connect here, okay, third position, RSH3 will be in parallel with the basic meter. Nothing but I can go for 3 different ranges. Basically, the meter will measure one range. Apart from that, I will go for RSH1, RSH2 and RSH3. So 3 additional ranges I can measure by connecting the switch in appropriate value, appropriate position. If I connect at 1, RSH value can be calculated with the help of certain formula. Okay, RSH1 equal to, we have just now gone through, RM divided by M minus 1, like that we can calculate. Now if you connect with RSH2, second position, so RH2 can be calculated. If you connect with RSH3, third position, RSH3 can be calculated. Now you see these expressions. So it consisting of three shunts, RSH1, RSH2 and RSH3, which can be used for three different current ranges, I1, I2 and I3 respectively. So in the first connection, we'll have I1 current. In the second connection, we'll have I2 current. In the third connection, you will have I3 currents. So I1, I2, I3 currents are passing through RSH1, RSH2 and RSH3. And IM is passing through meter. So we cannot change this IM current because it is the maximum current which can measure by the meter. So that will never change. If the input I is changing, according to that we can select which range of resistor can be connected in parallel with the meter. So if you want to measure I1, okay, nothing but I1 current is passing through RSH1, so that we can have one probability or one chance. Then let the shunt multiplying factors of I1, I2 and I3 will be M1, M2 and M3. So M1 is nothing but, we can have M1 is nothing but I divided by I1. Right. Now the multiplication factors. So M1 equal to I divided by I1, M2 equal to I divided by I2, and M3 equal to I divided by I3. So multiplication factor we can calculate as like this. Okay. Then how much amount of resistance can be added? So from the expression already we have gone through, RSH equal to Rm, nothing but the meter resistance divided by M minus 1. Now here we are having, instead of RSH, we are having RSH1, RSH2 and RSH3. Three resistors we are having. Now we are going to measure three different ranges of currents, I1, I2 and I3. So M1, M2, M3, three different multiplication factors can be obtained. So the same formula RSH equal to Rm by M minus 1. Here if you are using RSH1, so Rm divided by M1 minus 1. So see this. So RSH1 equal to, now RSH1 is there. So we are using M1. RSH2, M2. RSH3 and M3 we are using. So the remains same. Still the students are joining. It is not fair and good. RSH1, RSH2 and RSH3 we have obtained. So Rm divided by M1 minus 1. Next M2 minus 1, M3 minus 1, like that. So Rm will be remains constant because it is a meter internal resistance value. M1, M2, M3 are the three multiplication factors of shunt. So that if you add multiple, so there is a range selector switch will be there. This switch will connect either the position. Either if you want to measure I1 range, so that we'll connect to first position, second position, third position, like that. So multi-range. Now we can call this ammeter as multi-range ammeter. We can call this ammeter as multi-range ammeter. Okay. Now, okay, I hope this is clear up to now. Now, requirements of construction of shunts. So what is meant by requirements here? So how we are going to construct the shunts? So can you connect anything as you wish? Which type of material? In which position? So definitely there should having certain things will be there. So the coefficient of temperature of shunt and the instrument coil should be equal as far as possible and should be very low. So temperature coefficient value. So temperature coefficient value, why we are discussing means the resistance should not vary as the temperature changes. Okay, so whenever you are saying about Ohm's law, the basic definition for Ohm's law is at constant temperature. We are we are stating the Ohm's law as the words at constant temperature. The amount of voltage across the terminals is nothing but the amount of current flowing through and the product of the resistance. Like that, we can say the Ohm's law. Let it be. You are aware of that Ohm's law. Now we are saying about the temperature is constant. If temperature changes in the shunt, what will happen? The amount of current flowing through the shunt will change. So it should be temperature invariant. It should be temperature invariant. So like that, we have to select the material. And even if it not, then it should be a minimum change. Okay, definitely after certain range, as the current changes, as the temperature changes, the resistance will change. Okay, the best example for resistive load is electric bulb. In olden days, you might have seen the filament bulbs. There is a filament in the bulb where it is having a prepared with a tungsten material. That bulb can be treated as pure resistive load. Okay, the maximum percent of current is being diverted through the sheds, and they should not produce excess heat. So maximum percent of current should be diverted. Diversion means normal when we are going for the diversion of any for example, if you are moving in a highway, if any road repair is there, what will they will go for? They will make a diversion. So the diversion can have more number of vehicles are going to pass through the diversion, and very less vehicles should pass through the existing road. So nothing but bypass. Okay, and it should not produce excess amount of it. That's also one more thing. And their resistance should be time invariant. As I said already, the resistance should not vary with time, as should not vary with the temperature also. In case of AC instruments, the time constant of the shunt of the and the instrument coil should be equal. So time constant L by R, like that we can calculate. Tau equal to L by R. So that value should be constant for both instrument, nothing but the meter and the shunt value, right? They should have low thermoelectric EMF with copper. Okay, so here they should not have any thermoelectric EMF means because of temperature variations, there is a voltage variation also will be there. So that should not be very, very low. Okay, that should be very, very low. Now this is about the extending the range of ammeter. Now we are going for extending the range of voltmeter. Now the same explanation, similar explanation we can have. I will give a voltmeter, okay, which will measure 0 to 300 volts of range. Now this is the voltage, how much we can measure. Nothing but the meter. Now I am giving the input voltage V as 500 volts. So that 500 volts should be measured by this voltmeter. Is it possible? Of course not, because the meter will measure maximum of 300 volts. The remaining 200 volts, it is not able to measure by the meter. So we have to send or we have to allow only 300 volts to the meter. So it is not going to work beyond the range of values. So that's why what we are going to do here. So due to the difficulty in measuring of high voltages with normal voltmeters, it is therefore necessary to bring those high values of normal values that can be measured by the voltmeters. Correction. అన్నా మెయిల్ వచ్చింది, రేపు నేను ఆన్లైన్ క్లాస్లో ఉన్నాను. ఒక ఫస్ట్ క్వాలిటీకే పోదాంలే, ఫస్ట్ క్వాలిటీకి వెళ్దాం. నేను నీకు ఒక హాఫ్ అన్ అవర్ కాల్ చేస్తాను, క్లాస్ జరుగుతుంది. రైట్. యా, సో we need to measure higher range of voltage. This process is called extension of range of voltmeter. Now we are going to extend the range. In this, an external device is connected. External device in a sense, again resistor only here also. So external device is connected to the measuring instrument to increase the measuring range. So as we have seen in the ammeter, we are using a shunt path. So in the shunt path, certain amount of current is passing through the shunt, and the remaining current is passing through the meter. Nothing but there we have used a parallel circuit. In the parallel circuit, current is going to divide. In the parallel circuit, current is going to divide. But what about the voltage in parallel circuit? Voltage remains constant. But whereas in case of series circuits, the current will be remain same throughout the operation and voltage will be dropped. Voltage will be dropped. Now here what we can do, we can drop certain amount of volt, nothing but we can connect a resistor in series with the voltmeter so that that voltage can be dropped there and the remaining voltage only will pass through the meter. Okay. And here also we are going to use potential transformer or a multiplier. So multiplier, the topic what we are discussing right now, and about the potential transformer we are going to discuss in detail about the in the second chapter. So current transformer, potential transformer, these two topics we are going to discuss in second chapter. So only we are discussing up to multiplier range. So multipliers can be used for both AC DC voltmeters, while the potential transformers can be used only for AC voltmeter, that we'll discuss in detail about, because it's a transformer, it works only for AC supply only. Now see this diagram. We are applying certain amount of voltage V. So the amount of voltage V is nothing but here this amount of voltage we need to measure in this circuit, in this meter, nothing but in this meter, it is nothing but a voltmeter. This voltmeter has to measure this much amount of voltage. So this is the input voltage. This is the input voltage. This input voltage is being measured by this voltmeter, nothing but Vm, let us say. Okay. Now what we are, just observe this circuit diagram. Here we are using a multiplier. Okay. Earlier also we have used a multiplier. This is a resistor in which is connected in series. It is connected in series with the voltmeter. Now what will happen in the series circuit? Voltage will drop. Voltage will drop. So across this resistor, there is certain amount of voltage will be there. Okay, I will draw here. Okay. Vs. Here S stands for series. Earlier we have used SH, shunt resistor. Here it is connected in series with the meter, na? That's why it is represented with RS, series resistor. So across this resistor, certain amount of voltage will be dropped, and the remaining voltage only will pass through this meter. So if you want to measure some 500 volts with the range of 300 meter, 300 volts range meter, 0 to 300 volts meter range. So 200 volts should be dropped at the multiplier, and the remaining 300 only should pass through the meter. Now tell me, RS is nothing but the series resistance, RM is nothing but meter resistance. Which should be high? Again in a similar question as in case of previous ammeter shunt. Now tell me the answer in the chat box. RSS or RM, which should be high? I am waiting for your answer. Just think and give the answer in the chat box. I am waiting for your answer. RS is the series resistor, RM is the meter resistor. So RM and RS, which should be high? Joshit, no, bag you no, sorry. Bag. Yes, RM will be high. RM will be high. Okay, now you are going with RM. Everyone is saying RM is high. And can anyone say the reason? Okay. Rm. So here just observe, we should have certain amount of resistor. It should block the maximum voltage. As you said is correct. Rm should be high. Rm is more. So sorry, RS is more. RS is more. So maximum amount of voltage it is going to block at the multiplier itself. We are going to block the maximum amount of voltage at the multiplier. So if Rm is more, sorry, RS is more, then more amount of resistance can be blocked here. Okay, more amount of drop, because voltage drop is nothing but I into R, V equal to IR. So the drop across series resistor Vs equal to the current flowing through the circuit is same because it is series circuit. Okay, I into or Im into Rs. Im into Rs. Okay, so if Rs is more, Vs will be more. Nothing but IMRS, this product will becomes increase. As this product increases, automatically Vs also will increase. So maximum voltage can be dropped here, and the remaining voltage only will be sent to the next, which is nothing but in series it is connected with the meter. So maximum voltage we can drop at multiplier, and the remaining voltage only will pass through the meter. So here Rs is more. Now, the main function of the multiplier is to limit the flow of current through the voltmeter in such a way that the deflection of the pointer should not exceed the full scale reading. Of course, because here the voltage, if you reduce the voltage levels, automatically the meter will get less voltage, so that less deflection will takes place in the meter, right? Now we'll see the voltmeter should be connected in parallel or across the 2 points to measure the potential difference. Okay, so nothing but here we are going to connect a voltmeter to measure how much amount of voltage can be dropped across the multiplier and how much amount of remaining voltage can pass through the meter. Okay, now we'll see as usual the derivation. Get ready with your notebooks. Draw the circuit diagram also. Rm is nothing but the meter internal resistance. Rs is nothing but the resistance multiplier, resistance of multiplier, nothing but series resistance. Because S endu rasavante ikkada, that resistance has been connected in series with the circuit or in series with the meter. That's why Rs. Earlier we was connected in parallel. That's why RSH. Now Im, the full scale deflection current of the meter. V, the amount of voltage being measured. Okay, and Vm is the full scale deflection voltage of the meter. So Vm nothing but the full scale deflection, but as I said, it is a 0 to 300 volts range voltmeter. I am giving 500 volts voltage as input. So 200 should be dropped here, and the remaining 300 should pass here. Okay, because that meter can measure only 300, so that becomes Vm. Okay, now the same circuit, the multiplier we are going to calculating. So M equal to V by Vm. So earlier we have gone through M equal to I by Im. M equal to I by Im. In case of ammeter shunts. Now here M equal to V by Vm. So V by Vm. V by Vm, how we are calculating? V is nothing but the input voltage, which is nothing but the amount of current flowing through. Okay, that is I into R. Nothing, V is nothing but IR. I into the total resistance, because Rs and Rm are in series. That's why Rm plus Rs will be there. So that is nothing but here we are having the total resistance divided by Im value. Sorry, Vm value. Vm is nothing but the amount of current Im is flowing through the resistor and the resistance is Rm. So what will happen? Im and Im will get cancelled. So Rm by Rm plus Rs divided by Rm. Now if you again divide Rm by Rm plus Rs by Rm. So this will becomes cancelled. So it becomes 1. So 1 plus Rs by Rm. Nothing but m equal to 1 plus Rs by Rm. This is the value of multiplier value what we are going to use in voltmeter. Now from this we can calculate how much amount of resistance can be added. So Rs equal to, from this expression we can calculate m minus 1 into Rm. So cross multiplication. So m, okay, so take 1 as here, m minus 1 and multiply with Rm, so that we will get Rs. So Rs equal to m minus 1 into Rm. So this is the amount of resistance how much we are going to add. Okay. Now is it clear? So hence to extend a voltmeter range from m times, we are going to increase the voltmeter range by m times. So the resistance of the multiplier is required is m minus 1 into the resistance of the meter. So required resistance is nothing but Rs, which is equal to m minus 1 into meter resistance. Now similarly, as we have gone through with the multi-range value, so because in order to measure higher ranges of voltage values, as the value of V changes, okay, now see here we are using 4 different terminals. So range selector switch is there. If the switch is connected with the V1, this position, first position, V1 voltage, nothing but R1 resistance, R2 resistance, R3 resistance, R4 resistance, like that we will have. So that voltages are V1, V2, V3 and V4. Okay. Now we will have for individual resistor values are there. For nothing but the maximum meter currents will be there. So according to that we can have. So if it is connected to the first position, R1 Im current will flow through here, and the remaining voltage will be passed through the meter. So as we require V1 first position, V2 second position, V3 third position, and V4 is the fourth position. So like that we can have multiple parallel. Just observe here. At a time we are going to connect only one. We cannot connect 2 or 3. So if the switch is connected to the first position, this is the path of current. If switch is connected to the second position, this is the path of current. If switch is connected to the third position, this is the path of current. If switch is connected to the fourth position, this is the path of current. So at a time we are having only one resistor. So depending upon the position, we can have multiple values. Now we will see the ranges. So at position 1, V1 equal to Im into nothing but the total current. In the series, Im only will flow, Im into R1 plus Rm. At position 2, V2 voltage can be added here, nothing but Im into R2 plus Rm. V3 equal to Im into R3 plus Rm, and so on. So here R1, R2, R3, the relations are R1 is less than R2 is less than R3. If this is the case, then what will happen? The voltage ranges is V1 less than V2 less than V3, like that. Nothing but it is also in the similar fashion. So R1 less than R2 less than R3. If you are selecting like that, let us say R1, R2, R3, R4 like that. If the relation between R1, all the resistors, or R1 less than R2 less than R3 less than R4 less than and so on, if it is the relation, therefore we are going to measure the voltage ranges of V1 less than V2 less than V3 less than, like that. Nothing but if more resistance is there, more voltage we can measure. Okay. So hence we can obtain the different voltage ranges by using multi-range voltmeter. And here also there are several requirements will be there. So the construction of the multiplier should meet the following requirements. So it should be time invariant. The multiplier resistance should be time invariant. The temperature coefficient of the resistance should be small, as we said already. Even in the, this is applicable for both ammeter multi ranges as well as the voltmeter multi ranges, and non-inductively wound for AC meters. Of course, this we'll discuss in detail later. In practice, multipliers are made up of materials that have negligible temperature coefficients. Negative temperature coefficient materials like manganese or constantin. So R1, R2, R3, R4, such kind of materials can be used as the resistors used for the material used for the resistors are manganese or constantin, because they are having less temperature coefficient and time invariant quantities, and they are also reduce the errors due to the temperature changes also. And this is about the voltage multipliers, but extending the range of meters. Now, so with this, the first chapter as gets completed. Nothing but the except the problems we have completed. The in the errors and the random errors we have gone through some of the problems. Then deflection, nothing but MC meters, MI meters, we have discussed through online, and even extending the range of voltmeters and ammeters we have discussed in the 3 days. For the last 3 days, what we have discussed, that topic problems we are going to discuss in the Monday onwards in the physical class. Okay, so I will convert these PPDs into PDF and I will send to you and prepare the notes. Okay, as on your own, right? Now I am stop presenting. Anna, evaru? Is anyone is having any doubts? Do you have any doubts? So every day I have taken 1 hour class, and I am covering one topic only. So I hope this speed is sufficient. If you want add something, or if you want having more clarification, you can contact me. Now I am stopping the recording.